The following video is a submission for BreazeHome 4.0 for the Spring 2018 FIU Senior Project. The student is Richard Roda and the product owner is Dr. Masoud Sadjadi. Hello BreazeHome team member. My name is Richard and I am a student developer on the BreazeHome team for the Spring 2018 semester. The purpose of this video is to give an overview of the feature I've been working on, an API endpoint which will allow BreazeHome to conduct searches on county records pertaining to real estate. This is a first video in a two-part series. In the first video, I will go over the design and processes I implemented in order to bring this feature into fruition by building the API endpoint. First, let's go over how Miami-Dade County provides the data to its users. I will then provide a quick walkthrough on how this data was implemented into our own API, and here I'll give a short overview on each critical piece of an API endpoint, including the model, serializers, filters, views, and routing. Lastly, in part 2 of this video series, I will analyze the two main scripts I created that will import the data into our own API, as well as a quick demo of the API in action. As you can see on my browser, Miami-Dade County does provide developers with an FTP API in order to access county records, as shown here. The data is provided inside of a daily zip file, which is uploaded at approximately 9:30 p.m. Eastern Standard Time, as you can see here, and it has a naming convention of DLY_records_date. The date is month, day, and the 4-digit year. Inside each zip file is a CSV file. A CSV is a comma-separated file which will allow us to easily parse the data into our own database tables through the use of simple scripts. The CSV file contains all county records which have been added or modified on that specified date. Another thing to note is that Miami-Dade API only provides records from the last 30 days, as shown here. This is a bit of a problem for us, because here at BreazeHome, we would like to have the ability to conduct searches on records older than 30 days. So we will need to implement our own system to store all of the historical data we need. So the first question we should ask ourselves is, what does a CSV data look like? Luckily for us, Miami-Dade has provided a file descriptor document in this link. This document describes all the fields in the dataset, their data types, as well as a brief description of each. This document can be downloaded directly from the Miami-Dade Developer Portal. With this document, we can now begin implementation of the API endpoint by creating the first component, the model. Let's go ahead and minimize this, go into our virtual machine. First and foremost, what is a model? A model is the single definitive source of information about your data. It contains the essential fields and behaviors of the data you're storing. Generally, each model maps to a single database table. One of the benefits of using Django for our project is the ability to create these models easily. Django can create our model and implement the table automatically once a migration takes place. It will create a create table SQL query and create the appropriate table with the attributes you describe in the model. In order to define the model, I have created an app called County Records for my endpoint, and inside there is a file called models.py. Each model would be a Python class that subclasses Django.db models. So, as you can see by the import statement at the top of the code I'm showing here. We'll first start off by creating a new class and naming it county record, utilizing the models that we just imported. Each field in the model is an instance of the appropriate field class. For my feature, Django uses the field class types to determine a few things. First would be the column type, which tells the database what kind of data to store, so a char, an integer, a varchar, etc. I've also added a maximum length of each field, and if the field can be null or blank. For simplicity, these fields will have the same names, data types, and constraints that were described in the Miami-Dade file descriptor document. By having our model be an exact representation of the data we're receiving, importing and parsing this data would be a fairly simple task to do. In order to register our model into our application, we will need to create a file called admin.py in which you would register your model as shown here. Once this is done, we now need to let the main project, the Breeze project, know that we have created a new app and we would like to use it. We can do this by going into the Breeze folder and into the settings.py folder and searching for a section labeled Installed Apps. You'll find it around the top of the code. As you see here, here's the list of all the installed apps that our BreazeHome project contains. And on the bottom, I have added my newly created app called County Records. Now Django has access to the County Records app. Once this is all complete, we now need Django to insert the model we just created into its own database table. This process is known as a migration. Migrations are Django's way of propagating changes from your model into your database schema. They're designed to be mostly automatic through the use of two simple commands, make migrations and migrate. As shown here, I will create a make migrations command. Oh, my front end is right. No. Let's go into our breeze.api. We will now go ahead and activate our virtual environment. I personally have already done migrations, but I would just like to show you the right commands in order to get this going. So it's Python 3, make migrations, and the name of your app. My mistake. Forgot to add one more thing, manage.py. As you can see, no changes were detected in my model because I've already made my migrations, but that's okay. The second command you would like to run is Python 3, manage.py, migrate county records. What this will do is that it will make the changes needed on the database in order to hold your newly created models. A nice feature of migrations is that the migration files for each app are located in its own folder. As you could see, my county records has a migrations folder. This is designed to be committed to and distributed as part of the code base. You should be making these migrations once on your development machine and then running the same migrations again on your colleagues' machines and eventually on the production machine when it's time for deployment. By keeping track of all the migrations inside of the app itself, Django makes sure that the database tables are consistent throughout the entire team and at all stages of the development cycle. Now that we have that set up for our model and created a new table inside of our database that will contain our data, we will now create what's known as a serializer. So inside our app, we are going to create another file called serializers.py. Since we are using Django REST framework to construct our API endpoint, serializers are an extremely useful tool available to us. A serializer allows complex data such as query sets and model instances that can be easily rendered into JSON, XML, and other formats. In layman's terms, serializers convert our database entries into a universally readable JSON format that can be used by other applications accessing our API. So as you can see, we have made a serializer.py file, and we are importing the serializers from the REST framework, as well as the model county record that we just created. Through the use of this class function, we utilize the REST framework serializer on our model as specified here, and the fields we would like to serialize. For simplicity, we're going to go ahead and serialize all the fields inside of our model. This is a short command that will allow Django to know that you're mentioning all models and all attributes. It's double underscore all double underscore. So our serializer is done. We can now move on to the next step, which is creating our filter. We're going to go ahead and make another file called filters.py. A Django filter allows us to perform complex queries on our database, and Django will return a JSON with the matching results. This feature also improves API performance due to the fact that we don't need to load the entire dataset for every API call. We just need to receive the data pertaining to our query. The first step in creating our filter is to let Django know that we would like to implement it. Luckily for us, Django has a built-in filter called Django Filter Backend that makes this part of the development process pretty straightforward. In order to see the settings for the backend, we're going to go back into the Breeze files and going back into the settings.py file. And look for a section in this code that reads Default Filter Backends. Should be near the middle, maybe towards the end. Here we go. As you can see here, previous iterations of BreazeHome have used this filter already, so there's no need to add it. I just wanted to let you guys see where this is actually placed. Now that Django knows that we want to use filters, we will go ahead and fill our filters.py file. Let's go back into our app, County Records, into our filters. In this Python file, we will import the view set, the REST framework filters, and the county record model as shown here. We will now create a custom filter class called County Record Filter and assign it to the model it will use, as shown here, County Record. In this code, I wanted to make sure I can perform exact matching and pattern matching searches. Therefore, for each attribute, we use that command double underscore all double underscore. This is a special format used by Django, letting the API know we would like to perform all types of searches on these attributes. Some examples of searches would be equals, which Django would translate into a where clause in SQL. And another one is iContains, which Django will translate into a SQL-like clause. Please refer to the official Django documentation if you have any questions regarding this topic. And also, there are different types of filters you could use, and I would highly recommend going over that documentation. But our filter is now done. It's not that bad, is it? This project has definitely shown me the power of Django REST framework and how easy it can be to get an API up and running in no time. We're almost done. On to the view. The view is where all the things we have created come together. REST framework includes an abstraction for dealing with views that allows the developer to concentrate on modeling the state and interactions of the API and leave the URL construction to be handled automatically. We will go ahead and create a views.py file inside of our County Records app and then import the necessary modules to get a view set as shown here. We are also importing our serializer, our model, and the filter that we just created. The first class is Pagination. I will get back to that in a second. But we will create a county record view set and utilize Django's model view set module. Inside the class, we specify all the files we created and any other API options we deem necessary. As you can see, our serializer class is County Record Serializer. We're going to be ordering by all to give developers freedom when it comes to filtering and ordering their results. Pagination, which I will mention in a moment. We are using the Django Filter backend that I have mentioned earlier, as well as the filter we created. And then the query set is all the results from any query that's done on the database. An empty query will return the full data set, and then filter queries filter down your data set to the values and entries that are valid. Let's go back now to pagination. Since the county records table has the possibility to return hundreds of thousands of records, I have implemented the feature known as pagination. What it will do is that it will split large query sets into pages, allowing quicker load times when retrieving data. In my code, as you can see, I have set each page size to 100 entries. And this is our view. The final step in our API endpoint creation is to define the routing. Routing will allow us to bind our API endpoint to a specific URL for easier access. To do this, all we need to do is go back into the Breeze folder and open the urls.py file. As you can see, we are importing our view set that we just created. County records views, import county record view set. And we will now route our URL, county records, to the county records view set. What this allows is a new API endpoint on our system that will only deal with county records. This is good if you don't want to deal with agents, properties, themes, open houses, etc. And that's it. We have successfully implemented a new API endpoint in the BreazeHome database for our county records. Now that everything is in place, we can go ahead and begin bringing in our data. In part 2 of this video, I will be detailing the 2 scripts I developed in order to accomplish this task, as well as a real-time demo of the API in action. Thank you very much for watching, and I'll see you in the next video. For any questions pertaining to the video, please contact me directly at rickroda@gmail.com. If you have any questions regarding the BreazeHome project, please contact our product owner, Dr. Masoud Sadjadi, at email sadjadi@scs.fiu.edu. Thank you very much.